This question we have to find the slope of this polar curve at the intersection points. We cannot understand the slope from the polar coordinates because a derivative of r with respect to theta would not necessarily mean the same thing as we expect. So we want dy by dx, but how do we get there? We can get there simply by using chain rule. So we can simply use the chain rule that dy by d theta divided by dx by d theta should give you dy by dx. But you know y is r theta sine theta and x is equal to r theta cosine theta. Remember, these are both now dependent on theta. So when you take the derivative with respect to theta of y and x, they would apply the chain rule, not the chain rule basically, the product rule in differentiation. So we'll get something like this: r prime sine theta plus r cosine theta divided by r prime cosine theta minus r sine theta. So this is what you'll get. So you need this sort of a form to get the slopes at the specific points. So of course, to start off, we need to realize that the curves are a bit different, sort of a little weird, because they are squared curves. We've already done one square curve above, so you can check that out. But for this one, like always, finding the intersection point, you just need to equate these equations. So you need to say under root 2 sine theta equals under root 2 cosine theta, which simply means tan theta, because cos theta would go over here and become tan theta, is equal to 1. When is tan theta equal to 1? Very famously, that is 45 degrees or pi by 4. So your theta is pi by 4. So once you get theta equals pi by 4, you have to plug it in either of the equations and get the value of r, because it's you can plug it in either of them and you will get the same result. Sine pi by 4, which would give you 1, and because sine 45 is 1 over root 2, it cancels, and then r should equal plus minus 1. Okay, so the polar points of intersection are 1 pi by 4, this is of course this is r, this is theta, and minus 1 pi by 4. These are the two intersection points. We don't know the shapes of the curves, we can plot them and see, but we'll just go by simple algebra right now. So we have two intersection points. We can now do something to find out what is the slope at each of these points for both of the curves, because both of the curves would have a different slope at the intersecting point. In Cartesian coordinates, we can convert these simply because x equals r cos theta and y equals r sine theta. So we can simply convert them and we'll have something like root 2 by 2 root 2 2, which is 1 over root 2. You can just write 1 over root 2 1 over root 2, and the other point would give you minus sign, so you can write plus minus. These are the 2 points. Okay, when you have plus 1 by root 2, you have plus 1 by root 2 on the y-axis. These are the 2 points in Cartesian coordinate. Now we're in a position to find this curve, the slope on the first curve. The first curve is this. We need to use this at the appropriate theta to find the slope according to this curve, because let's suppose if there were two curves, this was the first curve and this was the second curve, and they were meeting like this, the slope according to the second curve is a little different than what it is for the first curve. So it is, of course, the slope depends on which function you're talking to. So we're talking to the first function now, and we'll find r, that would be under root 2 sine theta. Now you need to take the derivative of that Once you take the derivative of that, you should expect to get something like cos theta divided by 2 root 2 root 2 sine theta. Okay, something of this scale. Now what you need to do is just plug in r prime for each of the value, and of course r prime is now explicitly only a function of theta, so you need to plug in only the theta value, which is pi by 4. Once you plug in the theta value for all of these, you would exactly get dy by dx, which in this case should be something approximately minus 2.1 something. So if it is around that value, that would be good. Now if you were to find the slope for the other curve would have a different slope, slightly shorter in the negative. It's like minus 0.5 almost. For the other curve, you'll have to do the same thing. For the other curve, you'll have to take the derivative of this other curve and then plug it into the derivative formula. So this is how you calculate the slopes of points. It's necessary sort of to convert it to Cartesian coordinates because it's easier to understand slopes in Cartesian coordinates. The important takeaway is that dr by d theta doesn't give you the same thing as dy by dx.